Hi students, it's Mr. O, your physics teacher. Today I'm going to show you how to do all the calculations for your Barbie Bungee lab. First, you need to plot your ordered pairs that you measured. So that means you started with 2 rubber bands, 3 rubber bands, 4 and 5 rubber bands. And when you plot that, it looks maybe kind of something like this. And you have to make a line of best fit. So the line of best fit does not go through all the points. It may not even go through any points at all. But it goes sort of through the average of everything, and it makes a straight line. So in this case, you see this line goes through somewhere on the y-axis, and it goes sort of through the middle of all of these 4 points that you had. Here's an example of your collected data. Let's say I made measurements with 1, 2, 3, 4, and 5 rubber bands, and the distances that I measured, now these are not the ones that you have with your Barbies, I just made those up. Let's say with 1 rubber band is 35, 2 rubber bands 44, then 53, 66, and 68 centimeters. Next, I will take a graph and I will distribute those values on the x and y axis. So on the x axis, I have the rubber bands from 0 to 5, and on the y axis, I go a little bit higher than 68, maybe 70 or 80 or something, and that fills out my graph field. So this is what I did. You see on the x-axis the rubber bands, starting with 0 going to 5, and then I made 80 centimeters on the y-axis. I plotted all of those points here for 1 rubber band, 2, 3, 4, and 5. And then I made the line of best fit. Next, I have to calculate the slope. Slope is called m. Finding the slope n, and I'm using the slope formula. So m equals y2 minus y1 divided by x2 minus x1. Important here is that you have to pick 2 points for your x and y, 1 and 2, that are on the graph, so on the line, and that are easy to identify. What I did here is I chose this point. You see how this point goes through like 2 intersecting lines on my graph field? And I determined from my x-axis that would be at 2/3 of a rubber band and at 30 centimeters. So that's my x1 and y1 point. x1 is 2/3, y1 is 30. The other easy to identify point would be this one here, also goes through an intersection of 2 lines on my graph paper with corresponding to x is 5 rubber bands and y is 75 centimeters. So these are the 2 points that I identified easily. x1 is 2/3, y1 is 30, and then x2 is 5 and y2 is 75. Instead of 2/3, you could also use 0.67, which is what I did for my calculations. So now, to use this in my slope formula, I simply plugged in those points y2 minus y1, which is 75 minus 30, divided by x2 minus x1, which is 5 minus 0.67. So first you have to calculate the 75 minus 30, which is 45, and then 5 minus 0.67 is 4.33. Then you calculate that, 45 divided by 4.33, and you get a slope of rounded 10.4. It was like 10.39 or something. So I rounded it to 10.4. Next, you have to find the y-intercept, which is called b, using a point on your slope, and I used point y2. Remember, point y2 is this one here. That was at 75 centimeters. So I'm using that point to calculate the y-intercept. The y-intercept is the point where the line goes through the y-axis where x is 0. We didn't have any measurements, but since the Barbie has a certain size also, of course, if you let her jump with 0 rubber bands, does not mean that she has 0 height. You have the height of the Barbie then. The formula is this one here. Y equals m times x plus b, Y is the value on the y-axis. M is your slope. We already calculated that. X is the number of rubber bands, and then B is the y-intercept. So M we already calculated, and we said we're going to use the point Y2, which is 75, and that corresponded to rubber bands of 5, so X is then 5. We have to solve this equation for B. That means I have to get rid of everything that's with B. We have to get rid of M times X. This is how we do that. B equals Y minus M times X, because M times X is added to B, so to get rid of it, we subtract it from both sides. Now plug in my numbers. B is then 75, that was my Y2 point, minus the slope of 10.4 times the 5 rubber bands that corresponds with that Y2 point. And when I put that in the calculator, I get B equals 23. That's the y-intercept. When I check on my graph, that's about right. That point is at about 23. Now, this is what you have to do next. You have to find the number of rubber bands that you have to use from the rotunda, and you know how high the rotunda is. That's in centimeters, so that would be found on the y-axis. Since we have run out of space on our graph, we cannot just make this graph bigger and bigger and bigger to find where we hit the point on the y-axis that is as high as the rotunda, but we can do this mathematically. What is it that we need to find? We need to find the number of rubber bands, which is X. X-axis are our rubber bands. We're using the same formula. As an example, I used a height of 4 meters and 5 centimeters, or that's 405 centimeters. Let's say our Barbie wanted to jump from a height of 405 centimeters. That means she cannot exceed the 405 centimeters, because then she's going to bump her head, and that hurts. But she has to come within 50 centimeters, so that's not hard to do. The 405 centimeters, that is your Y value. That's what you plug it in for. We use the same formula. Y equals mx plus b. But this time we have to solve it for x. What we know is m, the slope, from our earlier calculations, and b, the y-intercept, also from our earlier calculations. So now we have for y a value of 405 centimeters, for m a value of 10.4, and b was 23. Before we plug those in, we're going to solve this formula for x. So who all is with x? M is with x and b is with x. We get rid of b first because it's just added. So we subtract b from both sides. That means we then have m times x equals y minus b. And now we get rid of m. M multiplies with x, so we have to divide both sides by m. That gives us then x equals y minus b divided by m. Now we can plug in the numbers. So the numbers we had was 405 for y, minus the 23 that we calculated b to be, and divided by the slope, which was 10.4. We calculate that, and we get 36.73. So we're supposed to use 36.73 rubber bands. Now, since we don't have 0.73 rubber bands, we only have whole rubber bands. Should we use 36 or should we use 37? If we use 37 rubber bands, then the Barbie would go more than the 405 centimeters, and she would painfully bump her head, so we don't want that. So that means we're always going to round down to 36 rubber bands, and that should keep her safe, but give her a thrilling bungee jump.